Hello. The pyrometallurgical production of copper from sulfide concentrates is a journey involving the gradual oxidation of copper concentrates in sequential steps. These steps are smelting, converting, and refining. Smelting, the first processing step. Reaction shows that the combustion of a chalcopyrite concentrate will form three phases: matte, slag, and gas. A third element on the reactant side is the fluxing agent, required to allow proper separation of the produced molten product, an oxysulfide mixture that, with the addition of a solvent, fluxing agent, in the proper proportion allows the formation of a sulfide-rich phase, copper matte, and an oxide-rich phase, liquid slag. The gas phase will contain the combusted sulfur in the form of sulfur dioxide. Mattes do not consist of polyions like those in slags. They appear instead to be best represented as molten salts. Their specific gravity is higher than that of slags, and so they form the bottom layer in smelting furnaces. Slag is a solution of molten oxides. These oxides include ferrous oxide from iron oxidation, silica from flux and concentrate, and other oxide impurities from concentrate. Oxides commonly found in slags include ferrous oxide, ferric oxide, silica, alumina, calcia, and magnesia. Small amounts of sulfides can also be dissolved in slags. From a value point, the slag phase is a residue from the smelting stage. However, from the metallurgical point of view, it has a predominant role to play to ensure proper refining of the metal-containing phase. The chemical and physical properties of the slag are therefore of paramount importance for an efficient metallurgical process. The ferrous silicate melts discussed in the previous section have been the basis for the slags used in most primary copper smelting and converting technologies. However, ferrous silicate slags have limitations. The most important is the need to control magnetite formation. In bath smelting or converting, this is a problem because the magnetite crust that forms during the initial reaction can act as a process barrier. The second is the relatively small window of compositions where the slag is molten at smelting temperatures. Ferrous silicate slags are relatively acidic, which makes it more difficult to use them to remove impurities form acidic oxides. The copper converting process. From the thermodynamic point of copper matte must be transformed to blister copper by further reducing the sulfur potential and increasing the oxygen. During the slag blowing stage, copper content in matte is increased by the elimination of remaining iron sulfide in the copper matte and formation of slags. Copper blowing stage will eliminate a small amount of the remaining iron in matte and gradually remove the remaining sulfur from copper sulfide. The copper blows will end when copper sulfide has completely converted. The last step in the copper making process is the refining of blister. The process consists of two steps: oxidation to remove the remaining sulfur, and reduction aimed to reduce oxygen. A detailed explanation of this process is given in next coming video. Thanks for watching.